Hey guys, today I'm going to be talking about your hardwired control units. So, where do you think your control unit is present? Okay, it's not present in your memory, it's not present in your IO devices. It is present in your processor. Your processor has your execution unit, your control unit. So, your control units are used to produce your control signals. Okay, so this is a type of a control unit known as your hardwired control unit, and there are various methods in your hardwired control unit that we'll be exploring. So the first one is a pretty simple method, and it was present in the early days in your initial processors. It is not an ideal method because you'll come to know your advantages and disadvantages. So basically, it is the most basic type of hardwired control unit, and it is represented in the form of table. So this is your table. Okay, so your columns. So basically, in your control unit, CU, let me write it down clearly. Yeah, CU, your input is nothing going to be your instruction, and your output is going to be your control signals. This is a very important thing that you guys should understand. So you're having your instructions as your column, and your S is nothing but your states. Okay, so your states are nothing but your T states. That's T states is nothing but your clock cycle. So in this, if you see example, let's say your I1 is an add instruction. Okay, in the first T state, this control signal is performed. In the second T state, this control signal is performed. Similarly, for different type of instructions, we're going to have different T states and different control signals. Let's say this is multiply and so on. Okay, so your rows represent your T states and your column represents your instructions. So this is, if you see, it's as simple as that. There's nothing much to decipher over here. It's pretty simple. So let's go over your advantages and disadvantages. Your advantages is nothing but it's the simplest, and it is ideally suited for your small instruction sets. So your initial processors usually had really small instruction sets, and so this method can be used. But if you see your disadvantages, as the instruction increases, the circuit becomes more complex. So let's take your example of your 8085 or 8086. If you see, this is a CISC type architecture, and there are a lot of instructions, and no way can you use this because your circuit is going to be really complex, and it will take decades to actually finish the processor if you use this type of method. And it's as tabular method is used, duplication is present. So what does that mean is, in my earlier lecture about your micro operations, I've talked about your example. You have your first T state, you have your MAR gets the value of PC, your second state MBR, third state. So these three states, your MBR, okay, will get the value from the memory, and your MBR will give the value to your instruction register, and PC is incremented. So this is going to be followed throughout irrespective of your instruction, and it's going to be add, subtract, multiply, or divide. So you're going to have a duplication of these kind of instructions over here. So you're going to have your same set of instruction here, same set of instruction here, because you'll need to fetch and decode all of them. So basically, if you see, there's a lot of redundancy and time consuming process. So that's why if you see, this is not a strong method. So in the next video, I'll be talking about a more efficient and a more brilliant method that you guys are going to be learning. It's going to be really interesting, so stay tuned for that. Thank you guys.